All right, time for a new chapter. Today is 2.1, solving equations graphically. So anytime we find a solution of an equation, it's a number that when we substitute for the variable produces a true statement. I can't say 2 plus 2 is 7. That's just not true. So two equations are said to be equivalent if they have the same exact solutions. For example, 3x plus 2 equals 17, and x minus 2 equals 3 are equivalent. And the reason for that is, if I solve these two equations, subtract the 2 over, 3x equals 15, divide by 3, x equals 5. Over here, add the 2 over, x equals 5. So these are equivalent because they both have the same solution. 5 is the only solution that works for both equations. The first way that we can check to see if or what value is the same for both equations, or if two equations are equivalent, is the intersection method. So here I have the absolute value of x squared minus 4x minus 3, and that's equal to x cubed plus x minus 6. To solve this equation, we can use the intersection method following two different steps. The first one is graphing the absolute value, and then the x cubed plus x minus 6 on the same screen. Find the x coordinate of each point of intersection, and that will be what our value is. So let's go ahead and do that. If I pull up my graphing calculator, I'm just on Desmos.com, what I've been telling you to use all year. If I pull up my graphing calculator, I type in abs. Maybe not. Hold on one second. Okay, I can't type in abs. I have to actually push shift, and then it's the key above enter. It's the backslash key, and that gives me a straight line. And then now I can enter my equation in. X squared minus 4x minus 3. Push shift 6. Then I have to push over, minus 4x minus 3, I believe it was. Shift, and then that enter key again. And that comes up with this graph. Next, I have to graph the other side of the equation, and I graph that on a separate line. So x cubed plus x minus 6. So x cubed plus x minus 6. And when I graph that, that gives me my second graph. Now to find my point of intersection, I have to look where these two graphs are coming together at. In order to do that, I can zoom in, and you can just click on the point, and that gives you 2.207. That's going to be my point of intersection. If I plug that in, that will give me a y value that's the same for both of those. And that's really it for the intersection method. In some cases, there will be more than one point of intersection, and you just have to make sure that they're not intersecting anywhere else. Like, I could keep zooming out on this, and these two lines are never going to cross again, the blue and the red. So I'm fine with the way that it is. Okay? But in some cases, you will see more than one intersection. Just something to look out for ahead of time. The x-intercept method is our next one. A point where the graph of f of x intersects the x-axis is of the form a0, where a is just some point on the x-axis, because every point on the x-axis has a y-coordinate of 0. The number a is called an x-intercept of the graph of f. So anytime that we are on the x-axis, that's where our x-intercept is when the graph crosses there. Let f be a function. If r is a real number that satisfies any of the following statements, then r satisfies all of the statements. So r is a 0 of the function f. R is an x-intercept of the graph of f. X equals r is a solution or root of the equation f of x equals 0. So if any of those is true, they're all similar to each other. They're all the exact same thing. And so if one of those is true, then it's true for all of them. Just a bunch of different phrases to say the same thing. So we follow 3 basic steps to solve an equation by the x-intercept method. Number 1, write the equation in the equivalent form f of x equals 0. So everything is going to be on the left side, and it's just equal to 0 on the right side. Then, step 2, graph y equals f of x. Step 3, find the x-intercepts of the graph. The x-intercepts of the graph are our real solutions to the equation. If I look at this equation, you'll notice that I have something on the right. It's not set equal to 0. So what I have to do is I have to solve this equation and get that right side over to the left side. How do I get all this over to the left? I'm going to subtract the x cubed and subtract the minus 5, or subtract the 5, making that minus 5. Whatever I do to the right side, I have to do to the left. X to the 5th minus x to the 3rd. We can't combine those terms because they have different exponents. Plus x squared minus 5. That's all equal to 0. Now I can just graph this equation. When I graph this equation now, I believe it was plus x squared minus 5. And let me get my regular table back. To go back to our beginning, I would just set this, go down to where it says x. And I just set that to negative 10. Set this one to 10. And same thing with my y's. I may have to zoom out later, but it's a good standard position to put it in each time. So now I can see where my x-intercept is at. If I can zoom in just by scrolling or like grabbing the mouse pad and pulling it apart. And I can click on this equation, and I see that my y is 0 here at the point 1.424. So that's my x-intercept, and I'm done, 1.424. Now what if I had asked you to do this on a homework assignment, on a quiz, or on a test? The easiest way to do that is you can save this. Like let's say this was question 2. You can click save. You can click this, copy, and you can just send me the link right in your assignment. So like under the comments of where you turn your assignment in, you write question 2 and send me this link. You could also export the image. I don't recommend that because it's going to save it onto your laptop or your Chromebook or whatever phone you're using, whatever you're doing to do this assignment. So I don't actually recommend exporting the image. I would just copy and share this link. If you wanted to get even better with the naming, you could say like 2.1 question 2, 2.1 day 1 question 2. That way you knew what that would be, or know that that would be that question when you look back at it, if for any reason you did. I'm not getting too concerned about the naming of it. Anyways, so once we solve that and we find our x-intercept just by clicking here, you can see it's 1.424. That's my final answer. Looking at the next one, it's going to be the same thing. Let's just go right in and graph it. This one's already set equal to 0. So let's put this graph in here. We're going to do the square root of x to the 4th. You know I'm not going to remember this. Square root. To get square root, SQRT, and it puts it in. X to the 4th plus x squared. Already forgot the rest. Minus 2x minus 1. Okay, whenever I graph this, we can see that it comes down and stops. But I have my point here at negative 0.405. You see over here, I also have a right side that comes down and stops. Important to note that you can have more than one 0. So you should always check for more than one 0. So I have one at negative 0.0, let's try that again, negative 0.405 and one at 1.184. And those are my two zeros, or roots, or whatever you want to call them. Okay, last regular problem. I have 2x squared plus x minus 1 over 9x squared minus 9x plus 2. Again, no way I remember this. I'm surprised I remembered that much. Plus x minus 1. Now, the thing I like about Desmos is that it can figure out what I'm trying to do. So I see that now I have it minus 1, and whenever I do the division sign, it's just going to be over 1 over the thing. I need the whole thing to be divided. So I got to put these parentheses in. And now when I push the divided by sign, you see it all goes up to the top. And I can finish my bottom out. 9x squared minus 9x plus 2. X squared minus 9x plus 2. All right, now when I look at this one, I can see that I have a 0 back here somewhere and negative 1. I have a 0 at 0.5, and I see that this one is going down, but it's never going to actually touch 0. It gets closer and closer and closer, but it'll never actually touch it. So that just leaves me with my two zeros. One at negative 1 and one here at 0.5. All right, tomorrow we're going to get into some word problems. I'm going to give you some homework on this tonight. Shouldn't be too hard. Make sure you're using Desmos. Even if you don't want to submit the graphs to me, just tell me what the zeros for each one are, and that's perfectly fine. Word of the day is going to be 0. So if you text me, or don't text me, email me the word of the day being 0. Let's go 5 bonus points on your chapter test. All right, so I'm going to give you those those regular problems tonight. We're going to work on word problems a little bit tomorrow, and then be done with this section pretty quick here.